Hello student, let's see the question number 24. What is this question, student? Very simple. Dinitrogen and dihydrogen react with each other to produce ammonia according to the following chemical equation. So this is the chemical equation they have given, N2 plus H2. They are giving the 2NH3. So we have to always write the balance equation. Here hydrogen is 3 and here hydrogen is 2. So after writing the balance, we have to write the balance. N2 plus this is the 3H2, it is going to give student 2NH3. This is the one thing. The first one, calculate the mass of ammonia produced if 2 into 10 power 3. So 2 into 10 power 3 means what? 2000 gram dinitrogen react with 1000 gram dihydrogen. So here they have given 2000 gram and this is the 1000 gram. So student, this is based on limiting reagent because the amount of both the reactants are different. So what we have to do, we have to calculate the moles and then limiting reagent we have to find. So what I am doing here, student, that is I am finding the NN2. So if you are finding NN2, so that is it is going to be gram mass over molar mass. Gram mass they have given 2000 gram, molar mass of N2 student. 1 nitrogen is 14, so 2 nitrogen is 28. And here is the N and mole of H2 is gram mass over molar mass. So what will be there, student? Gram mass over molar mass. So molar mass of H2 is how much, student? This is the 2. So gram mass is going to be 1000 and molar mass is 2. So dear student, you can divide this one. 2000 by 28 equal to, it is 71.4 mole. And how much, student? This is the dividend, that is 500 mole. Now dear student, what we need to do, we have to divide with the coefficient. Here coefficient is 1 and this is coefficient is 3. For LR, what we have to do, divide with the coefficient. So that is 71.4 divided by 1 and here is 500 by, what will be there, student? Coefficient is 3. So what will be there, student? 500 divided by 3. So it is going to be 166.6 and this is 71.4. This is the. Now student, what you are going to see here, this is the more, this is 1. So lowest value is limiting reagent. So N2 is LR as its value is less. Here this value is coming less, that is limiting reagent. Now this limiting reagent will finish first, so we have to use this in the calculation. Now again you write the question, N2 plus 3H2 giving 2NH3. So this is excess, student, there is no use of this one now because the N2 is deciding the product. So here you can write 1 mole N2, 1 mole N2 gives what, student? 1 mole N2 gives 2 mole NH3, 2 mole NH3. Now what we can do, student, 1 mole N2 gives 2 mole NH3. So dear student, you can write in the gram also. So 1 mole N2 means what? 28 gram. 28 gram N2 gives how much, student? 2 mole. Mole into molar mass is gram. So that is 34 gram NH3, student. 34 gram NH3. So 1 gram N2 gives, student, 1 gram N2 gives how much? 34 by 28 gram NH3, right? So how many gram available, student? You are having 2000 gram. So therefore 2000 gram N2 gives, student, how much it will give? So 34 upon 28 multiply by 2000 gram NH3. So dear student, you can divide this one. 34 multiply by 2000, dear student. So divided by 28. So 2428.57 gram NH3 produced, student, produced. Now the second question you see, student, second one, will any of the reactant remain unreacted? So H2 is remains unreacted, remains unreacted as it is excess reagent. It is more in quantity, excess reagent, student. Now the third point, student, third point. If S, which one and what would be its mass? If S, which one and what would be its mass? So N2 plus 3H2, it is giving 2NH3. Now, how much amount required? You have to correlate this one. So dear student, let us see. 1 mole N2 required how much, student? 3 mole H2. 3 mole. So we can write 28 gram N2 required. How much, student? 3 mole H2 means 3 to the 6 gram H2. So 1 gram N2 required, student. Required how much? 6 by 28 gram H2. So ammonia nitrogen we are having how much, student? In the question 2000 gram. So 2000 gram N2 required. 2000 gram N2 required how much, student? 6 multiplied by 2000 divided by 28 gram H2. So dear student, 12,000 it will be there, student, divided by 28. So 428.57 gram H2 used, right? So unreacted H2, student. So total H2 minus used H2, total H2 how much is there, student? Total H2, so 1000 is there, student. Use H2 how much? 428.57. So minus 1000, dear student. So it is the remaining is the 571.42 gram remains unreacted, student. Remains unreacted. So this is our required answer, student. This is the, I have checked this one. This is the absolutely correct answer. Thank you very much for watching, student. You go step by step and you will get the correct answer. Thank you.